Welcome. In this video, we'll be programming this machine called conveyor belts turntable roll line. Uh, First thing first we need to test and validate the labeling if it is made correctly. So this input here is input 9, and the labeling here on the motor for this direction is Q5 and Q6 according to the labeling. The sensor here, it's I6, that one, it's I5, the next one, it's I3, and we have I1 and I2 there. So this one is I1, the other one is I2. We need to validate whether they are normally closed or normally open. And the other one, there is I4, and then the last one is I7, which is an infrared. And then all these are metallic. They cannot sense anything except metallic sensor. These ones are metallic, and we have two mechanical switches which you actuate them or activate them by pressing them. They're more like push buttons with a spring return. Okay, so on my screen now I have a blank page like this. If you don't know how to select which program you do, so this one is function block, this one is ladder. In this video we will be doing strictly the ladder diagrams. Okay, so we'll start with I9. We want to check the status of I9. And I'm going to test it with my nearest possible output, which is the Q6 or Q5. I'll choose Q6, and then I connect like that. Okay, and then I download the program. Okay, program is in. I need to now to test it on the machine. I go to online test on the program, click online test, and I go to this spectacle diagram, the specs. It's starts close operator monitoring. Then I start the program. Then now when I press I9, Q6 goes forward. I9 is my push button. I need to show you what I therefore do. I will write on it. This will be my push button start. Okay, and this one will be my conveyor. Even if I can say first conveyor, we're going forward. It goes forward. Okay. Next up, I must test I6, in which it is the similar input as I5, I3, I4. Okay, I6 is my point A. That's my point A. I'll just label it point A. Actually, I was supposed to test I5, but it's fine. I6 is still fine. Okay, then let's test. Okay, and this one I'm gonna televise it or project it as a software base so that you can see and learn the difference between different types of inputs. So I'm exposing my workpiece, and you see I6 is a normally open. Then I need to do my I7, which is the infrared. I need to confirm my I7. That point E, actually the last point now. It's an infrared, it's a different sensor, that's why I am testing it. Okay, this one I'm going to project it. Okay, I'm going to put my hand on it and see what will happen. So I7 is also a normally open. Now I'm left with I1 and I2. If you can notice something, I1 is not yet pressed, so I'll test with I1 because I2, that other side is pressed. This machine is intended to revolve anti-clockwise 90 degree and then come back clockwise again. Excuse me. So I'm going to test I1. I'm going to test I1. I'll label it S1. If the motor goes negative 90 degree, it's going to go here on this sensor. I will give it a name like this: S1 negative 90 degree. The other one is going to be S2 positive 90 degree. So if this sensor is a normally closed sensor, it means that when it's pressed, nothing will happen, and when it's not pressed, there will be some action happening. So I need to press it to make sure that we are on the same page. So I've pressed it and I put on my motor mode. Okay, and nothing is happening. I want you to see also the screen. On the screen, nothing is happening. When I release, something is happening. So this one is a normally closed. You see, normally closed. But at the same time, I want you, so I1 and I2, they serve the similar purpose. I want you to see something. I'm gonna put Q1 here. Q1, Q1 at a negative 90 degree. It goes negative 90 degree. So I'm actually labeling the direction at which it's going to. It's going to negative 90 degrees. So just like that. So what it means is that okay, so let's see what will happen with Q1, which is the anti-clockwise 90 degree. The negative stands for anti-clockwise. The more you write long names, the more problems you're gonna face on a later stage. At the later stage. So I've pressed my I1 again, and it's blue. So this time around, I want to show you how my I1 will play out. So this machine must rotate anti-clockwise until it gets to I1. Then when it reaches I1, it needs to stop, and it does indeed stop. Okay, so I2 is opposite of that, and Q6 it goes forward. Then now we're left with Q7. Let's see Q7. Q7 is my last conveyor. Last conveyor held. Okay. Excuse me. Okay, and we cannot use I1 because it's pressed and it's normally closed. I prefer using probably I5 so that I can label it now. My I5 is at point B. Point B. So this testing and labeling at the same time also assist us with programming. When we need to program, we wouldn't require anymore to label some of the items that we are using at this moment. So yes, labeling as you go along, it's advisable. As you test, it's advisable. So now as last time I didn't project I5, I6, let me project I5 then. When I5 is active, you can see it's clearly visible that Q7 goes forward on the other side. So now we've tested everything, and I prefer to put back my I2 and Q2 to its initial position. So I must go to back, this is my S2 plus positive. I'm always forgetting this, but I see it in time, at least this time around. So S2 90 degree positive, you see that? 90 degree positive. It's very critical to be able to differentiate. So now this This is going to be Q2 also, so that this could go to its resting position. Q2 is positive 90 degree. Alright, like that, it's perfectly. So I'm not gonna project it. This one, without a doubt, I am going to let it run like this. Look, it's red. Oh, it ran too quickly before it could even show us there. Now it's blue again. It has moved to its initial position. So now it's time to program. It is time to program. So right, escape, delete. Okay, and then we start with I9. I9 is my start button. Put it on here, and it is followed by Q6, the motion. Q6 is the motion that we need currently. It goes forward, and that, okay, this one is Q6, and it's gonna go until obviously I3 is there, and it must stop at I3. So I need to place I3 there, like that. But I3 needs to be anomaly closed because it needs to break the signal. I3 needs to break the signal. I3 needs to break the signal. It's at point C. Point C. Then after that we connect just like that. Connect. Lovely. And then we need to know one thing. There is a conveyor belt here. This is a conveyor belt. So if we say the product must move from here until I3 there, it means that this conveyor belt needs to power on at 5. So I need to put I5 there, which is my point B, and I need to put Q3 according to that. So Q3, it's my, so it's on the turntable. Turntable, I can describe it as TB. uh, forward direction of the turntable. See that forward direction of the what of the turntable. I can just write this one in full. Forward. Okay. And that forward direction is going to be stopped by I3. I can easily copy it and paste, move it down there, and create a contact there. Contact for the relay, memory relay for Q3. Now this can be demonstrable. This is demonstrable. Okay. I press. Doesn't know. It's not yet ready. Now it's ready. When I press loop Q6, Q3, and they both stop. Practically on the other side, how does this looks like? Looks like this. Okay, and they both stop. So we are at the point where this needs to turn. This needs to turn clockwise and anti-clockwise, which is Q1. And this needs to be the representation of Q1, and it needs to stop by I1 at I1. It is very important to note that I1 is normally closed, therefore it's at 90° S1. Okay, that's my 90° S1. I1 is normally closed, therefore I use a normally open there. And this is activated by I3. This is activated by I3, which is my point C. I1, it's normally open, normally closed according to its physical connection, its physical state. It's allowing current to pass, therefore we put a inverse of that. This is the inverse. This will twist 90° negative or anti-clockwise until I1 is pressed. Until I1 is pressed. It is critical for me to show you how the software reacts. So I won't rush rush to go to the display. I'll just show you how the software reacts. I need to close this. Okay. So it happened automatically. I3 is pressed. This one is blue now because of it's at I1, and it looks like this. It is twisted. Now when I1 is pressed, I'm expecting both this conveyor to go forward, which is Q4, opposite of Q3, and Q7 to be activated. So I1 is pressed. I1 needs to come twice. Here and here. Okay? Activating two things. And one of them is Q4. Q4 is going to always press escape after positioning something to be safe and delightful. You're not going to have problems when you do that press escape button. Okay. Now the other thing that is critical here is the direction of the Q4. It's the turntable backward, TB backward. It's going backward, opposite of Q3. So, like that, lovely. I can even put my Q7 ready there, which is the last conveyor belt, and my Q7, I don't know, let's leave Q7. My Q4 is going to be stopped at I4. And I need to change this to be Q4 and press escape, connect this, okay, connect there, connect this, connect that. Then now this one comes there as Q7, retaining coil for Q7. Q7 is not going to stop at I4. It's only going to stop at the infrared, which is I7 point E. I7 what? Point E. And this one is point D. Okay, perfect, lovely. Then now we are going to test the program, how it will play out. Let me make you observe it. So, at this direction, I1 is pressed, I1 will activate two things. Q3, Q4 and Q7, which will allow these the workpiece to go and pass I4. At I4, it is expected that Q4 will stop running, and at I7, it was expected that the, everything stops. So now let's observe. Let me push it a little bit. See, they don't stop. They don't stop. Let's observe the program. They don't stop. I1 is pressed. I1 is pressed. It needs to be depressed in order for these to stop. How do we do that? We do that by introducing Q2. Q2. So Q2 is positive 90-degree. Movement, positive 90-degree. And it's going to be activated by I4. When we reach it, when we pass point D, we are expecting Q2 to return back. And as it returns back, it needs to memorize and it will stop at I2, original point, I2. So this is I2, which is my S2. This is my S2, positive 90 degrees. This code naming, I just came up with it. It's good for you to be able to label everything. Otherwise, you're gonna face challenges. Challenges that you wouldn't be able to solve that easily. Okay, I see my 90-degree. It's closed. It's not supposed to be a closed. It's actually an open one. I2. I'm surprised why the comment is gone. I don't know why, but it's fine. If it wants to disappear, let it disappear. This one is 90-degree direction, 90-degree positive, clockwise in other words, and it's going to stop at I2. So this is okay. This is S2 actually. It's not just the direction. It's S2. It's S2. This. All right. We are reaching the end of our program. This goes there. Perfect. Lovely. So now let's see if I1 would return back. And it doesn't return back. But what makes it to return back? It's the metallic sensor at I4. I'm gonna carry a metal object and head directly to I4 to observe. See? Perfect. Then this one needs to be stopped by the infrared. It was stopped by the infrared. Now, placing my item there nicely, and I start my program. And voila, it goes, it spins, goes on top, it gets stuck, it managed to go successfully, and voila, the program is a success. How does this looks like on the software? So it looks like this. Press I9 and I let go. And the item goes to point B. And Q3 is on. And item gets to I3. I3 is on. Q4 is on. Q1 is on. Q7 is on. Observe when we get to I4. You see, when we get to I4, Q4, Q2 are off, Q7 is remaining, and it gets deactivated when we get to I7. And the program indeed is complete. Programming of a conveyor belts turntable roll line. This machine used to be supplied by Stradinger in Germany, but you can still search it for it on internet and you'd still be able to find it. So thank you so much for viewing this video. If you like it, please press the like button, and if you have any query, please leave it on the comments. And if you haven't subscribed and you like the content that I'm producing, please subscribe for more videos to come in the nearest future. Thank you so much for watching. See you next time.